Hello everyone, welcome to the channel Understanding.Concepts.Of.Physics. Here we are with the last numerical on oscillations, and in the next video we'll be starting with some other topic, and you can just go through this question and read the technicalities about that. I'll just highlight the important points. So there is a wooden block whose mass is m and it is kept on a piston that can perform vertical adjustable frequency and amplitude. So you can adjust the frequency and you can adjust the amplitude as well. Now in an engine of a bike or a car, you see the frequency is adjustable, however the amplitude isn't. But in some other piston we can adjust the amplitude. So the piston may oscillate at a smaller amplitude or maybe at a bigger amplitude as well. Then the frequency, if you can see, the frequency can be adjusted, or the frequency can be adjusted. So you can see the frequency, the timing of that. So they are saying that during this vibration we don't want the block to leave the contact with the piston. I'll just show you how it is in the diagram. How much maximum frequency is possible if the amplitude of the vibration is restricted to 25. So we do not want to reach the amplitude more than 25 centimeters. So what should be the frequency so that the block to leave the piston? Okay, so no, we don't want the block to leave the contact. So what is the maximum frequency with which you can vibrate it? And the second aspect is how much energy per unit mass is utilized in this. And G is approximately equal to pi square, which is approximately equal to 10, is been given to you. So amplitude is A stands for amplitude. This is 25 centimeters. I have converted that into meters, centimeters to meter, 10 raised to minus 2. Pi square and G ka value is given as 10 meters per second square. So everything is in SI systems now. Now I'll show you the diagram where I have showed you this is a rigid support. So this is the rigid support. This is not going to move. This is not going to shake. And then there is a spring attached to the rigid support, and there is this span or a piston. Okay, a piston can look something like this. So this is that piston, okay, and this piston is attached to some wheel, and as this wheel rotates, this piston goes up and down. So when this piston goes up and down, this block at some point, if you just keep on vibrating faster and faster and faster, you will find out this block is sometime going to leave the contact, and it will just start to bump on that, tuck 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 tuck, like that. So this is what the system is. Now here the problem is going to crack if you understood that if this is your mean position, this is your positive extreme, and this is your negative extreme, the block is going to leave the contact only when it is at the positive extreme and not at the negative extreme and not at the mean position, because the piston, when it goes up, it is going to take the block up, and only when the piston turns down, that's the moment where the block can leave the contact. Okay, the block will not leave the contact at the bottom, the block will not leave the contact at the middle, that is mean position. Block will only leave the contact at the positive extreme. Now when the block is leaving the contact, if you see there is some space I have shown you, okay, that's almost leaving. So at that point there is the net force acting on the block is because of only gravity, only gravitational force Fg is acted upon this block, because if it is leaving the contact, there is no normal force, and because if it is leaving the contact, there is no restoring force as well, only force is because of the gravity, because this is in the gravitational field. So I can say that the net force is downwards, and that is equal to the gravitational force. This is where the problem is going to crack. What are they asking? They are asking frequency, and they are asking what is the energy per unit mass. So let's just see. So I have shown you why the gravitational force is equal to the net force, because if it is leaving the contact, there is no restoring force, there is no normal force, there is no restoring, there is only one force, which is the gravitational force. So I can say that the gravitational force itself will be my net force. Now if gravitational force is mg, my net force will be mass into times acceleration. Now note that amplitude is written as a, but acceleration is written as acc. Now m and m gets cut, and acceleration due to gravity is equal to the acceleration. Now understand that, okay, why is the block going to leave this surface? It is because the spring has pushed the block very fast. That means it is because of the acceleration of the spring that has made this block fly. So acceleration due to gravity is equal to acceleration, and this acceleration will be because of the acceleration due to spring. So acceleration in a spring is omega square a, the maximum acceleration. Now actually the acceleration is minus omega square x, but we are ignoring the minus sign. On top of that, x, why are we writing as a? Because the block is going to fly only at the positive extreme. So acceleration is minus omega square x. At the extreme position, x ka value is a. So that's the reason why we are writing acceleration is omega square a. I have mistakenly written m over here, so I'll just erase that. Okay. So now I got as acceleration due to gravity is equal to omega square a. This is the maximum acceleration. Okay. Now omega can be written as 2 pi f. So I have written as 2 pi f. I have squared it, so I get 4 pi square f square into a. A stands for amplitude. I want f, so I'll make f as my subject and everything on the other side. So 4 pi square goes on that side, a goes on that side. So g upon 4 pi square a, and square when it goes on the other side, it will become a root. So root of g is as it is, root of a is as it is, root of 4 is 2, and root of pi square is pi. So that's just half solving. Then g ka value they have given as pi square, so I have written as pi square. I could have written 10 as well. Acceleration, amplitude is given as 25 into 10 raised to minus 2. This is given. Now pi square and root will get cancelled out. You get only pi. 25 ka root is 5. 10 raised to minus 2 ka root is 10 raised to minus 1. The pi and pi gets cut. 5 2s are 10, and 10 and 10 raised to minus 1 gets cancelled, and what remains is 1 hertz. So your final answer will come out to be 1 hertz for frequency. Now the second aspect, what they are asking is energy per unit mass. So I'm using the formula because it is in simple harmonic motion. I can say that the energy supplied at this point when it was at the mean position, this is the same energy it is going to acquire at this position. Okay, or rather I can say that the total energy in a spring. So total energy in a spring is half of Ka square. This is the total energy of a spring. So half of, in place of K I write as m omega square, because we know that K is equal to m omega square. Now m we don't want here. Anyway they have not given, they have not asked us to find out. So I'll take this m on the other side, so it will become E upon m. E is equal to half of 2 pi f the whole square. Now in place of omega I have written as 2 pi f the whole square. M has gone on the other side, a square as it is. Now put in the values. This is something I need to find out, so I'll keep it as it is. Half remains half. 2 square will become 4. Pi will become pi square. F will become f square, a square. Now let us put all the values. This 2 ones are 2 twos are, so I get only 2. Pi square I can write as 10. Frequency I found out as 1. And amplitude is given as 25, 10 raised to minus 2 the whole square. So 2 as it is, 10 as it is. 1 square is 1, we don't write it. 25 ka square is 625, 10 raised to minus 2 ka square is 10 raised to minus 4. And if you multiply 625 to 2, that will give me 1250, and 1250 into 10 will give me 12500 into 10 raised to minus 4. 10 raised to minus 4 will shift the point from this position to 1, 2, 3, 4. So I get 1.25 10 joules. 1.25, that is my final answer. And because it is energy, the unit is joule. Because it is mass, the unit is kg. So joule per kg becomes the unit of this thing, which is they have asked E upon m, that is energy per unit mass. So that's it for today. We have solved this numerical, and we'll be starting with a new topic in the coming videos. Thank you so much for watching. In case you haven't subscribed the channel, kindly do so, and watch all the videos from the playlist fully. Thank you so much. Have a nice day. Bye.